We're going to start our discussion of number systems with the Egyptians. Their system wasn't the oldest. That title goes to the Sumerians, but it is, in some sense, the most simplistic. For centuries, we had access to Egyptian hieroglyphic text, but it wasn't until the discovery of the Rosetta Stone, with its versions of the same text in multiple languages, and the analysis of it by Jean-Francois Champignon, that we were able to effectively translate those texts. Now, these early texts, they shed some light on how Egyptians used numbers, but they didn't really show us anything about their understanding of mathematics and mathematical operations. Our earliest insights into how Egyptians really approached numbers as a tool is the remnants of a scroll called the Wren Papyrus. It's named after Alexander Henry Wren, a Scottish researcher who purchased two pieces of it in Luxor in 1858. You may also see it referred to as the Alms Papyrus, after the scribe who copied it from a now lost text around, it was about 1550 BC. So what do we learn from these sources? Well, the Egyptian number system is based on 7 characters, what today we would call digits, each of which represents a power of 10. So for example, if you had a number like this, it would have represented 1,000, 300s, and 2 ones, or 1,302. Now, before I go any further, I want to emphasize that despite the use of the powers of 10 over there, this does not mean that this system has a base, like our modern decimal system. In that kind of system, the position of a digit within a number tells you something about the quantity it represents. For example, the 8 in 81 tells you that the number includes 8 tens. In the Egyptian system, the order of the digits isn't meaningful in the way it is with the decimal number. So, for example, this number would also represent 1,302, despite the rearrangement of those digits. Now, a significant issue with this method is its inefficiency. For example, writing 99 would require 9 heel bones and 9 strokes for a total of 18 symbols versus the much more compact 2 that our modern decimal system needs. Now, it does feel like the Egyptians had some awareness of this, and you'll sometimes see large groups of digits packed together like I've drawn them here. It doesn't reduce the number of digits, but it does help, a little anyway, to kind of optimize the space needed to write it. So arguably, the biggest contribution that the Egyptians made to number systems in general was the first use of fractions, although it was in kind of a limited sense by our modern standards. Egyptians represented so-called unit fractions, like 1/20th, as the base number, 20, under an oval that looks kind of like a mouth and was usually translated as part. Now, while they were very comfortable manipulating these unit fractions, more general proper fractions like 4/5 or 9/13 were really a mystery to them. Now, with that said, they were comfortable with the fraction 2/3, which had its own special symbol here. But other than 2/3, the Egyptians seemed to consider proper fractions as being somehow incomplete, in the sense that today we would consider something like 4/8 as being unfinished, in the sense that it can be reduced to 1/2. Now, an Egyptian would similarly consider 9/20ths as incomplete, since it could be rewritten as 1/4 plus 1/5. Now, if this seems complicated, it wasn't exactly easy to the Egyptians either. The Wren Papyrus, for example, includes a reference table showing these sorts of decompositions of fractions into the sum of a bunch of unit fractions for upwards of 100 common fractions. So our next step, again, kind of moving conceptually rather than temporally, is going to be to take a look at Roman numerals, which a lot of people already have some familiar with. Still not a positional system, but we are going to see some steps that will help to, at least in part, address that efficiency issue that we talked about here.